Unit 3C, Lesson 2. In the beginning of this lesson, we're going to determine whether a given function is even, odd, or neither. And then at the end of the lesson, we're going to find the inverse for a given function. First thing we need to do is relate an even, odd, or neither function to the graph. If we have an even function, it will be symmetric with respect to the y-axis, which we can see down below. If we have f of x equals x squared, we have that mirrored image that is created about the y-axis. It's reflected about the y-axis, so that is an example of an even function. An odd function will be symmetric with respect to the origin, which essentially means it's rotated 180 degrees about the origin. So if we have f of x equals x cubed, if we would take this function and rotate it 180 degrees about the origin, it would lie on top of itself. So that's why that is an odd function. And then the last one, a function that does not satisfy either of these conditions, is referred to as neither. So if we had f of x equals x squared minus x, we can see if we went about the y-axis, this is not symmetric. It does not create that mirrored image. And if we tried to rotate it 180 degrees about the origin, it would not lie on top of itself, so that's why that is neither. We can also use algebra to determine whether a function is even, odd, or neither, so we can look at a graph as well as use algebra. If a function is even, that's going to be true if f of negative x is equal to f of x. A function is going to be odd if f of negative x is equal to the opposite of f of x. So we're going to go through a few examples next showing what this notation refers to. So in the first example, we want to use algebra to determine whether a function is even, odd, or neither. The function we have is f of x equals 2x to the fourth minus 3x squared plus 9. So what we're going to do, everywhere we have an x in our equation, we're going to replace it with negative x. If we replace every x with negative x, we get f of negative x equal to 2 times negative x raised to the fourth power minus 3 times negative x raised to the second power plus 9. Now we're going to take the right side of this equation and simplify. If we have negative x raised to the fourth power, any value raised to an even power, whether it is positive or negative, that result is going to end up being positive. So we can simplify this down into 2 times x to the fourth power. Because this quantity is raised to an even power, this result is always going to become positive, so we can eliminate that negative. Same thing in the next part. We have negative x raised to the second power, which is even, so that negative is going to get canceled out essentially in the end, so this will become x to the second, and then plus 9 at the end. So after we have this simplified, we want to look and compare our result to our original. We had 2x to the fourth minus 3x squared plus 9, and we end up with 2x to the fourth minus 3x squared plus 9. So we end up with f of x being equal to f of negative x. If that result is true, we get f of x equal to f of negative x. That implies that we have an even function. Now in the next example, we have f of x equal to 7x cubed minus x. We want to use the same process. Everywhere there's an x, we're going to replace it with negative x. After substituting negative x in for x, we get f of negative x equal to 7 times negative x raised to the third power minus negative x. Same thing we did last time. Now we just want to simplify the right side of this equation. Now we have a negative x raised to an odd power, so that is still going to be a negative value. So we have 7 times negative x cubed, and then we're subtracting a negative x. If we're subtracting a negative, that's the same thing as addition. The only thing we can do is bring this negative value out in front, so we end up with negative 7x cubed plus x. So just like the last time, now we're going to compare our results with the original. Our original was 7x cubed minus x. What we ended up with was negative 7x cubed plus x. looking at the signs in front of each term, our first term was positive in the original. What we ended up with was negative. Our second term was negative. What we ended up with was positive. If all of our terms switch signs, which essentially means that f of negative x is equal to the opposite of f of x. So if we plug in negative x for x and all of our terms change to the opposite sign, that implies that we have an odd function. So to summarize how we can use algebra to determine whether or not a function is even, odd, or neither, we're going to substitute negative x in for x into our original equation, simplify that equation, determine whether or not our signs stay the same or switch on our terms. If all of our signs stay the same, it's an even function. If all of the signs switch to the opposite, then it is an odd function. If there's a combination where some signs switch and some don't, then that is neither. The last thing we are going to talk about in this lesson is finding inverses for functions. There's some general steps we're going to follow when trying to find the inverse for a function. The first step is we're going to replace f of x with y. The second step is interchange or switch our x and y terms. Third step, solve for the new y variable. The fourth step is make sure the new equation still represents y as a function of x. And then the fifth step is we're going to replace y by f raised to the negative 1 of x. This notation represents that is the inverse function. So the first function we're going to find the inverse for is f of x equals 7x plus 4. Step 1 tells us we need to replace f of x with y. So we're going to get y equals 7x plus 4. Second step is now we're going to interchange or switch our x and y terms. So if we interchange x and y, our new equation is x equals 7y plus 4. Now we get to step 3, which tells us we want to solve this equation for the new y variable. So we need to get y isolated by itself. First step would be subtract 4 to the other side. So we get x minus 4 equal to 7y. The next step would be divide by 7. So now I just rewrote this to make it a little easier to see. We would end up with y equals 1/7 x minus 4/7, because when we divide that whole side by 7, we have to divide each of these terms by 7. So we have x divided by 7, which is 1/7 x, and then 4 divided by 7, so minus 4/7. Step 4 tells us that we want to make sure that y is written as a function of x, which essentially means that we have y isolated by itself in terms of our x variable, and that this is still a function, which it is in this case. This is just a linear function in slope-intercept form. So now the last step, we want to replace y with f raised to the negative 1 of x. This notation represents the inverse function, equal to 1/7 x minus 4/7. So that's the process of going from our original function to find its inverse function. The last example, again, finding the inverse for a given function. We start with f of x equals x cubed minus 4. First step, replace f of x with y. So we get y equals x cubed minus 4. Second step, interchange our x and y variable, which would give us x equals y cubed minus 4. Now we want to go through and get y isolated by itself. First step would be add 4 to the other side. So x plus 4 equal to y cubed. Now in this case, to get y isolated by itself, if that variable is cubed, we will have to take the cube root of each side of the equation. So we're going to take the cube root of the right side, which means we have to take the cube root of the left side. So now I'm just going to rewrite this so it's in an easier form to recognize. We would have y equals the cube root of the quantity x plus 4. Step 4, again, a little confusing, but just tells us we want to make sure y is isolated by itself in terms of our x variable, and that is still a function, which it is. So the last step would be to replace or substitute f to the negative 1 of x in for y. So we get f to the negative 1 of x equal to the cube root of the quantity x plus 4. So we started with f of x equals x cubed minus 4, went through this process to find its inverse, which is f to the negative 1 of x equal to the cube root of x plus 4.